You're listening to DTFHN for March 15, 2026. I'm your load-bearing hallucination of a host, Jack Hacksman. We are your daily tech feed for Hacker News, a website where everyone's an expert on the thing they just learned exists. Today, the mood is systems that were right all along while everyone yelled at them for it. Strap in. I once spent 3 weeks debugging a system that kept corrupting Japanese text. Turned out the entire pipeline assumed every character was 1 byte wide. Not a bug, exactly. More like an act of breathtaking cultural provincialism baked into the foundation. The system worked perfectly, as long as you only ever fed it English. Spotify has built the same thing, except for music. Charles Petzold, the programmer and author, not a crank, recently tried Spotify's AI DJ for classical music and discovered something wonderful in its awfulness. The entire metadata architecture assumes every piece of music is a pop song. 3 minutes, 1 artist, 1 title. Done. A Beethoven symphony. 4 movements designed to be heard as a single dramatic arc. Gets atomized into 4 separate songs with no indication they belong together. The AI DJ will cheerfully serve you the 3rd movement of the 7th Symphony wedged between a random Debussy prelude and a Vivaldi concerto movement ripped from its context. This is like a library cataloging system that assumes every book is a pamphlet. You ask for War and Peace and it hands you Chapter 37. The comedy deepens when you realize this isn't an AI problem. It's a data model problem. The metadata schema, artist, album, song, was designed in the Napster era for 3-minute pop tracks, and nobody ever revised it. The AI is doing exactly what it was trained to do. It's optimizing brilliantly within a structure that is fundamentally illiterate about 500 years of musical tradition. You can build the most sophisticated recommendation engine ever conceived. And if your ontology can't represent the concept of these 4 tracks are actually one piece, you're going to produce nonsense. Garbage in, garbage out. But now with a friendly voice and a confident score. What gets me is that this is a solved problem. Music Brains, an open community-maintained music database, has had proper work-level metadata for years. Composers, compositions, movements, relationships between recordings. The knowledge exists. The schema exists. It's sitting right there, open and free. Spotify chose not to use it, or more likely, never considered that music might be more structurally complex than verse, chorus, verse. The Hacker News comments are predictably divided between who cares about classical music and people who actually understand the architectural critique. One commenter dismissed the whole article because, quote, the term DJ is synonymous with electronic music, which is a bit like dismissing a bridge collapse because you personally prefer boats. The real lesson is older than software. Your data model is your worldview. Whatever your schema can't represent, your system will pretend doesn't exist. And when you bolt AI onto that blind spot, you don't fix it. You just make it talk. Systems pretending things don't exist. Let's flip that entirely, because this next story is about building systems that grow things into existence. In Julme Niner Buschafischevi, Vannevar Bush published As We May Think, describing a desk-sized machine called the Memix that would store and cross-reference all of a person's books, records, and communications. 80 years later, we have server racks that do exactly that. And now, apparently, someone is growing lettuce in one. A developer ended up with two 42U server cabinets, but only needed about 10 units of rack space. The door frame was installed after the cabinets were wheeled in, so the spare one isn't leaving without a fight, rather than filling it with more compute. And this is the part worth lingering on. They explicitly said they want less computer, not more. They've always dreamed of quitting computers and starting a farm, so they built a hydroponic flood and drain system inside the empty rack. The engineering is straightforward. Sterilite storage boxes fit a standard server rack almost perfectly. A 72-liter reservoir on the bottom, 38-liter grow trays on rack mount shelves above. Submersible pump pushes nutrient solution up. Adjustable drain fittings control the water level. An air stone keeps the reservoir oxygenated. The whole thing runs on a switched PDU. A power distribution unit, the same hardware that would normally be toggling servers on and off. There's apparently a fifth element reference hidden in the cron tab, which tells you everything you need to know about the builder's priorities. The flood cycle runs a few times a day, just long enough to wet the roots. Grow lights on a timer handle photosynthesis. The author freely admits that flood and drain is, according to strangers on the internet, the worst way to grow anything other than mold and algae. But it's simple, and simple means buildable. Follow this to its logical end. A server rack is a climate-controlled, power-managed, precisely ventilated enclosure with standardized mounting hardware and remote switching capability. It is, by accident, a reasonable growing chamber. The infrastructure we built to keep silicon alive at precise temperatures turns out to work for keeping plants alive too. The rack doesn't care what's drawing power from its PDU. Meanwhile, Singapore just opened a 5-story automated vertical farm using essentially the same principle at industrial scale. Racks, lights, nutrient solution, scheduling. One person looked at an empty cabinet and saw a farm. The tools were already there. They just weren't being used for what they're good at yet. Moving on. There's a line buried in Mathematica's documentation for arccosh that most people skip right past. It says, quote, arccosh of z has a branch cut discontinuity in the complex z-plane running from negative infinity to positive 1. That single sentence explains why one of the most sophisticated computer algebra systems on Earth, Ray-Fi U axdis, believes to tell you that sinh of arccosh of x equals the square root of x squared minus 1. Because it doesn't. Not always. Let me show you the craft here. When you type sinh of arccosh of x into Mathematica, it hands back this expression involving the square root of x minus 1 times the square root of x plus 1. Kept separate, not combined. Your first instinct is that the software is being obtuse. Just multiply those together under one radical and simplify. But Mathematica knows something you forgot. That simplification assumes the square root of x plus 1 squared equals x plus 1, and that's only true when x is at least negative 1. For x equals negative 2, sinh of arccosh of negative 2 returns negative root 3. The naive simplification gives you positive root 3. Wrong sign. The software was right to re-exfol Ryan. This is genuinely elegant engineering. Mathematica is not failing to simplify. It is correctly representing a function whose behavior depends on choices made in the complex plane. Specifically, which side of a branch cut you approach from. Defining arccosh for all complex numbers requires removing the real line from negative infinity to 1, defining the function everywhere else by analytic continuation. Then carefully choosing limits from above along that cut. The square root function demands the same care with its own branch cut along the negative reals. Imagine if every computer algebra system just did the naive simplification. Run this forward. Students would get clean answers that happen to be wrong for half the complex plane. Engineers working with hyperbolic functions in signal processing or relativity would get sign errors that only manifest at specific input ranges. The bug would be nearly invisible because the formula looks right. One commenter nailed it. It's not obvious that the square root of x squared simplifies to x without further assumptions. This is a general pattern in computer algebra. The system isn't being difficult. It's being precise in a domain where precision actually matters. What I admire is the design philosophy. Mathematica chose correctness over legibility. It could easily pattern match and return the clean form with a footnote. Instead, it returns an expression that evaluates correctly everywhere in the complex plane. The documentation tells you exactly where the branch cuts are. The algebra tells you exactly what it means. The tools are all there. You just have to read carefully enough to understand why the machine is smarter than your intuition. Sometimes the real branch cut is between what you owe the world and what you're willing to give up. Like a treasure hunter who chose jail over surrendering shipwrecked gold. The strongest case for keeping Tommy Thompson locked up goes like this. He took investor money. He found 3 tons of gold on the ocean floor. He sold some of it, pocketed the proceeds, and when a federal judge ordered him to account for the rest, he refused. For a decade, civil contempt exists precisely for this situation. It's not punishment, it's coercion. The key to the cell is in the defendant's own pocket. Comply with the court order, walk free. The system gave Thompson every chance and he chose the cell. That's not injustice, that's consequences. Now let me explain why that argument fails on its own terms. Civil contempt is designed as a temporary mechanism. The legal theory, and this matters, is that detention compels compliance. The moment it becomes clear that detention will not produce compliance, the justification collapses. 10 years and 7 months. Thompson is now 74. At some point, and reasonable people can disagree about exactly when coercive detention becomes punitive detention wearing a different label. And punitive detention without a criminal conviction, without a jury, without the standard protections of criminal procedure. That is an architecture problem. One of the commenters cut straight to it. Civil contempt can net you an indefinite prison sentence without a conviction. And if you're lucky, a judge will decide to let you out over something you may or may not even be able to produce. That last part is critical. Thompson claims the coins went to a trust in Belize. Maybe that's true. Maybe it's not. But the system has no mechanism for resolving that ambiguity. It just keeps holding you until someone with a robe decides you've suffered enough. There's no statute of limitations, no mandatory review, no external accountability. Run the architecture test on this. Who controls the system? A single judge. What checks exist on that power? Essentially none that functioned here for over a decade. What happens when the coercive rationale no longer holds? Nothing automatic. The system has no self-correcting mechanism. Thompson may well be a fraud. The investors who funded his expedition deserve answers and probably deserve money. But the tool the legal system chose, indefinite civil detention, reveals something uncomfortable about how much unchecked power we've built into institutions we assume are functioning correctly because they're ours. The gold is genuinely interesting. 3 tons from an 857 shipwreck 8,000 feet down. But the story that matters here isn't about treasure. It's about a man who spent longer in jail for contempt than most people served for violent crimes, in a system with no upper bound and no automatic review. and we only talk about it because the gold makes good headlines. We talked earlier about protocol shaping power. Let's talk about a protocol trick that's genuinely beautiful. When did we decide that two computers wanting to talk to each other was a problem that needed solving? That's the absurdity at the heart of TCP hole punching. The internet was designed so any machine could reach any other machine. Then we ran out of IP addresses, bolted on NAT as a temporary fix in the mid-90s. And now every peer-to-peer connection requires an elaborate negotiation ritual just to do what the network was built to do in the first place. One of the Hacker News commenters called NAT one of the most idiotic own goals in the entire field of networking, and honestly, that might be underselling it. But here we are, and Robert has published something genuinely delightful. A TCP hole-punching algorithm that strips away all the usual infrastructure. No SDN servers, no signaling channels, no coordination service, and replaces it with a single insight. If both sides can agree on what time it is, they can derive everything else deterministically. Pull this thread, both machines grab the Unix timestamp, apply a formula that accounts for up to 20 seconds of clock skew, and land on the same number. The bucket. That bucket seeds a pseudo-random number generator, which produces a shared list of ports. Both sides bind to those ports and start punching simultaneously. No server told them what to do. No third party brokered the introduction. They converged on the same plan independently, like two strangers showing up at the same cafe because they both follow the same logic. The trick with the ports is beautiful in its optimism. It assumes your home router will preserve the source port in its NAT mapping. A property called equal delta mapping. That won't work everywhere. The author knows this and says so plainly. Coverage is sacrificed for clarity. And that trade-off is the whole point. This isn't production infrastructure. This is a test harness for the punching algorithm itself, isolated from every other variable that could muddy the results. What I love about this is the posture. The entire NAT problem exists because we papered over an address shortage with a hack that broke end-to-end connectivity, then built billion-dollar relay infrastructure to work around the hack. Robert's approach says, forget all that. Two machines, a shared clock, a little number theory. The tools are right there. Sometimes the most radical act in networking is just letting computers do what computers were always supposed to do. Talk to each other directly. We've covered a lot of ground today. Let's shift gears completely. Pause. Ever wonder what's actually happening when your kernel becomes a trust enforcer? Ring zero. That's the phrase that matters here. When you install a kernel anti-cheat, you're granting a video game company the same privilege level as your antivirus, your disk encryption, your entire operating system's security model, and the engineering required to make that work. And work without crashing your machine is genuinely extraordinary. Let me break this down to first principles. Your CPU runs code at different privilege levels. Ring 3 is where your applications live. Your browser, your game, your cheat software if you're that person. Ring 0 is the kernel. It can see everything, touch everything, override everything. A cheat running at ring 3 can be caught by anti-cheat at ring 3. But a cheat running at ring 0, now your ring 3 anti-cheat is completely blind. It's asking the kernel for information, and the kernel is lying to its face. The article walks through the full stack of how systems like BattleEye and Vanguard actually operate at this level. They hook kernel callbacks. The same ones Microsoft designed for security products. They scan memory structures most programmers will never encounter in their careers. Vanguard loads before Windows even finishes booting. These aren't simple watchdog programs. They're full kernel drivers doing real-time integrity verification on the operating system itself. But here's where the engineering admiration meets the architectural question. Every one of these protections has been defeated. Kernel cheats got blocked, so cheat developers started exploiting legitimately signed drivers with known vulnerabilities. Bring your own vulnerable driver. BYOYD, anti-cheat added block lists. Cheat devs moved to hypervisors, running below the kernel, virtualizing the entire OS, so the anti-cheat doesn't even know it's being watched. And now, there are PCIe DMA devices. Custom FPGA hardware that reads game memory directly through the bus, never touching the operating system at all. The software layer literally cannot see it happening. The comments on this one are sharp. Multiple people point out the obvious. All this kernel access has led to actual security breaches. Players have been compromised through buggy anti-cheat drivers. You're trusting a game studio with root access to your machine, and their incentive is catching aimbots, not protecting your bank credentials. The real first principles question is whether the entire client trust model is broken. Several commenters push toward server-side anomaly detection. Statistical analysis of player behavior rather than kernel surveillance. Cheaters are definitionally anomalous. They act on information they shouldn't have. That's a pattern recognition problem, not a kernel access problem. The most interesting engineering path forward might be the one that doesn't require owning your operating system at all. Moving on. One commenter nailed it. They said they love looking at the code samples, having absolutely no clue what any of it means, and thinking about how many non-English speaking programmers must feel that way looking at Python every single day. That's the moment, that's the mere flipping. Korean is a compiled programming language where every keyword is Korean. 함수 instead of function. 만약 instead of if. 반복 instead of loop. It compiles to native binaries through LFMIA, ships with the interpreter, has rapport, ILF, LABO, ILSP server, structs, closures, pattern matching, generics. This isn't a toy. Someone built a real tool chain in Rust and a keyword happened to be in Hangul. And the question nobody in that comment thread wants to sit with long enough is, why in 20 Alex is this still a novelty? Hangul is one of the most systematically designed writing systems ever created. King Sejong commissioned it in the 15th century specifically so ordinary people could read and write. The entire script was engineered for accessibility, and yet, 600 years later, if you want to write software, you learn English keywords or you don't write software. Someone in the comments proposes a simple keyword translation layer for Python. Just map def to funku, list to mo group. Straightforward, right? And then you realize every library, every error message, every Stack Overflow answer, every tutorial, every API doc. The keywords are the thinnest layer of a deeply English infrastructure. Localizing if and while is a weekend project. Localizing the ecosystem is a civilization scale effort. That's what makes Han interesting beyond the technical achievement. The compiler is open source, written in Rust on GitHub. Anyone can fork it, study it, extend it. Another commenter points to Nuri, a functional Korean language that goes even further. Not just translating keywords, but designing syntax around Korean grammar itself. These projects won't replace Python. They don't need to. What they do is make a point that most of us native English speakers have never had to confront. We've been programming in our mother tongue this whole time. and calling it universal. We talked earlier about tools meeting people where they are. Pause. Story 8 takes that idea somewhere deeply personal. Every communication channel has a noise floor. Shannon proved this in 1948. You send a signal, the channel adds noise. The receiver has to reconstruct the original. For 78 years, the goal of communication engineering has been the same. Reduce the noise, recover the signal. LLMs do the opposite. Sebi Wilkin wrote a post this week that frames this precisely. When someone runs their message through an LLM before sending it to you, the model doesn't just clean up grammar, it replaces the signal. Your word choices, your cadence, your particular way of being too blunt or too cautious or slightly wrong in a way that tells me something real about what you're thinking. All of that is signal. The LLM treats it as noise and strips it out. The devil's advocate position is obvious. Surely clearer communication is better communication. If someone's a non-native English speaker, or dyslexic, or just bad at writing, why wouldn't you want a tool that smooths the rough edges? One commenter makes exactly this case. They're French, they use Claude to translate, and the result communicates their intent more accurately than their raw English would. But, fair enough. Translation is a different operation than replacement. When you're converting between languages, you're trying to preserve signal across a channel change. When you're running your native language message through a genericizer. Wilkin's word, and it's the right one. You're destroying signal within the same channel. The deeper point is about protocol. Human communication isn't just payload delivery, it's a synchronization process. Every message you send me carries metadata in its imperfections. Your typos, your comma splices, your habit of burying the actual request in paragraph 3. I learned to read those patterns. They become part of our shared protocol, and LLM resets that protocol to factory defaults every single time. One commenter reports their company had to explicitly tell employees to stop using ChatGPT for internal messages. Not because of data security, because people stopped being able to tell who actually wrote what, or what anyone actually meant. The tools exist to help us communicate. When they start communicating for us, the channel is still open, but nobody's on it. Moving on. I once spent 3 weeks writing compliance middleware for a system that didn't need it. The spec was so broadly drafted that our team couldn't figure out if we were covered or not, so we built the infrastructure just in case. Cost us a sprint, shipped nothing of value. That memory came flooding back when I read about Ageless Linux, because someone finally gave that absurdity the response it deserves. California's AB 1033 requires operating system providers to collect age information from users during account setup. The law defines an operating system provider as anyone who develops, licenses, or controls the operating system software. And here's where Ageless Linux drives the point home with surgical precision. It's a bash script. It modifies one file, etc. US release to declare itself a new Linux distribution. Under the law's own definitions, that's sufficient. You are now a regulated operating system provider. Congratulations. This has the same energy as Phil Zimmermann publishing PGP's source code as a printed book in 1995 to exploit the distinction between arms export regulations and First Amendment protections. The government said cryptographic software was a munition. Zimmermann said fine, it's also speech, and books are protected. He didn't fight the law on its own terms. He made the law fight itself on his terms. Ageless Linux is doing exactly that. The law says you must collect age data per affected child. But you identify an affected child that through the age data the law requires you to collect. Without collection, there are no affected children. the enforcement mechanism requires the violation it's supposed to prevent. The law eats its own tail. Their words, and they're right. What genuinely impresses me is the forward-looking architecture of this protest. Right now, there's nothing to remove, so the script is the whole distribution, but they've committed to maintaining removal tools, fork packages, and spins that strip out whatever age collection infrastructure the major distros eventually ship. A permanent immune system for the ecosystem. One commenter pointed out that freedeskcubdent.org was already drafting dbus interfaces for age verification compliance. Ageless Linux saw that thread and built the antidote before the poison shipped. The tools exist, the knowledge is available, and somewhere in the Linux ecosystem there will always be a distribution that treats you as a person of indeterminate age. That's bootstrapism at its finest. Now for something completely different. Let's talk about the pure, geometric joy of slicing Bezier surfaces. De Castillo publishes algorithm in 1959 while working at Citroën, designing car bodies. The math stayed locked inside the company for over a decade. Proprietary knowledge used to shape sheet metal. Meanwhile, Pierre Bezier at Renault independently developed nearly identical mathematics and published openly. Guess whose name stuck? The curves are called Bezier curves, not the Castillo curves. APADA. Open publication won the naming rights to history. That tension between keeping geometric knowledge close and sharing it freely is still alive 65 years later. Fadi Ericli just published a clean walkthrough of slicing Bezier surfaces. The two-dimensional extension of those curves. Using nothing but JavaScript and linear interpolation. The technique is surgical. You take a surface defined by 16 control points. A 4x4 grid that shapes a smooth patch. And you split it at any parameter value t. The split uses de Castillo's own subdivision method applied to each row of control points independently. What you get back are two surfaces that together reproduce the original shape exactly. No approximation, no mesh artifacts, no loss. Then you iterate, slicing the remainder again and again until you've carved the surface into as many pieces as you need. This is the mathematics that powers every CAD program, every 3D modeling tool, every font renderer on your screen right now. And here it is, laid bare in maybe 40 lines of readable code. No library dependencies. No framework. Just LERP. Linear interpolation. Applied recursively until curves become surfaces and surfaces become editable geometry. There is something quietly radical about publishing the internals of surface editing this plainly. The professional tools that do this. The Rhinos, the SolidWorks, the Alias product. Charge thousands of dollars per seat. The math underneath them is public domain, has been since Bezier chose publication over secrecy, but the implementations stay locked behind proprietary walls. Every time someone writes the algorithm from scratch and puts it on a blog, they're completing the circuit that Bezier started. The knowledge stays free. The tools stay reachable. This has been your daily tech feed for Hacker News for March 15, 2026. This podcast is entirely AI-generated. Scripts by Claude Opus 4.6. Voiced by Calming3TTS. Not affiliated with Hacker News or Y Combinator. Now go build something with tools you already have. We'll see you back here tomorrow.